Hi guys, welcome to our YouTube channel. I'm Greg Royani. Today I'm going to present on set theory. Under set theory, I'm going to deal with only the basics under this topic, set theory. First, I may define what's a set. And simply, a set is a collection of distinct objects. A set is a collection of distinct objects, or what we call members or elements. So we have two major ways of representing a set. So the first way is using the set builder notation. Then the second one, we have the list method of set representation. So the first one, talk about the set builder notation. In this case, we have a set being represented by a common feature. So in this case, let's say a set A having element X. So these are mathematical symbol meaning X is an element of A, written this way. This means an element or simply belongs to, meaning X belongs to A. So back to our example, let X be an even number or even numbers in set A. So you can write A is made up of X such that X are even. So the connotation even represents the other elements in the set A. Or simply can use A, let's say Y, such that Y are odd. The odd term represents the whole of the other elements in the set. Then the second one, talk about the list notation or list method. Under the list notation, this is where there is no common feature in between the elements. Let's say A comprising of elements A, B, C, D, and 1. So there's no common feature in between these elements. Meaning, we just represent the elements as they appear as per the what? The set. Remember, in set theory, repetition, let's say A is not meaningful. So in this case, we just write A if there are 2 or 1. We have 3 major set operations. So in this case, I may start by the first one, what we call the union of a set. The union of a set, these are the elements that are in the first set, the set, let's say A, or in the second set, let's say B. So let A be denoted by the elements A, B, and C, and B denote the elements A, C, and F. So in this case, the union of A, written A union B, will be the elements that are in A, B. So it is A, B, C, and F. The repetition in this case is material. You can repeat A and A. So we write A, B, C, and F. Then representing on a simple Venn diagram. A Venn diagram is simply a pictorial representation. This mathematical symbol. So you can have A and B. So you have A, B, and C. Then you have A, B, and F. So both elements in between the two sets, set A and set B. These are universal sets. Second property or second operation is intersection. Under intersection, these are the elements that are both in A and B. Using our above example, intersection of A and B is written A intersection B, inverted U. So in this case, we'll pick up elements that are both in A and B. So using a simple Venn diagram, can draw A and B, having A, B, and C, and F. So the elements that are both in A and B are A, B. That's why the intersection of A and B given in the same examples here, so it will be 1, A, B. These are the two elements that are there in common. Then lastly, under the operations, we have a complement, or simply complementation. The complement of a set A is written A complement. So in this case, when representing such on a Venn diagram, you draw A. These are universal sets, meaning our complement will be outside A complement. This means the complement of set A is in the what? Universal set. Our universal set is the bigger set, comprising of what? The set A. In set theory, we have again an instant where you can have A intersection B and find that you get nothing. What I get is the intersection between the two, they don't have any element in common. Let's say A having 1, 2, 3 as the elements, and then B having A, B, and C. So in this case, they have none of these elements which are common. So in this case, their intersection is a 5. This is a Greek word. They call it 5. So in this case, we have no element of intersection. So in this case, it will be written A intersection B is nothing. These are sets without anything. Or A intersection B, then you write the 5, meaning there is nothing. Or A intersection B is 5, nothing in that set. So we can simply draw that set representation in the Venn diagram. Can draw the Venn diagram with our universal set, meaning A and B. These are A, these are B. The elements are 1, 2, 3, and A, B, C. They have no elements of intersection. Then we can talk about the subset. Subset. For clear understanding of the term subset, you can have when a set A have all elements representation in set what? In set B. We say A is a subset of B. When they say A is a subset of B, it's normally written a subset of B, meaning both elements in A are in B. That's why we write the symbol with a line. A subset of B. And meaning B is a super sum of A. When A is a subset of B, you have just said that A or both elements in A equals to both elements in B. It's also possible to write A equals to B, meaning the set A and B are equal because they have the same elements, the same measures. Let's say A can be A, B, and C. Also, B will be C, A, B. So we have A, B, C and C, A, B, A, B, C. They have the same elements, A, B, and C. So in this case, they are equal. When the two sets are not equal, you can say A is not a subset of B, written that way, or B is not a proper sum of what? Of A. Meaning the two sets A and B have no common elements, or the elements are not similar. Then lastly, let us finalize with a question. In this case, we have a question which is a survey company sampled 1,000 students at a university, out of which the sample 550 students smoked cigarette, 820 drank alcoholic beverages, and 470 did both. So let's attempt this question. In this case, we can represent the information in a simple Venn diagram. So you can have our universal set, then you have A, you have two sets there. So you have 550 students smoked cigarettes. So let's say these are cigarette smokers, and then these are alcoholic what? Beverage drinkers. So we have this one, 550 students smoked cigarette. So we have, and then we have 820 drank alcoholic beverages, and 470 did both. So 470, they did both. They both smoked cigarette and drank alcoholic beverages. Then we have 550 smoked cigarettes. So 550 minus 470, in this case, you get this 80. So meaning 80, they only smoked cigarettes. Then in this case, we have 820 drank alcoholic beverages. So take 820 minus the 470. So you get 350, meaning only 350 drank alcoholic drinks. So let's answer the first question. The first question asks about students who smoked or drank. So here our first A will be smoked or drank alcohol. So we have this C union A. So in this case, we have 80 plus 470 plus 350. So which will be 1,000. All the students who smoked 900. They smoked and drank alcoholic drinks. Then B. So we have students who drank but did not smoke. They drank but did not smoke. So in this case, they drank is A. They drank alcoholic and did not smoke. So in this case, we check they only drank alcoholic and did not smoke. So we check is what? 350. These are the students who only drank alcoholic drinks. Then third, we are talking about the C. Students who neither drank nor smoked. Neither drank nor smoked. So we have students who smoke cigarettes, their union who drank alcohol, but they neither do the two activities. So in this case, we take the whole sample, we minus, we got our first answer as student who smoke and also drank alcohol. So we take minus 900. So we get in this case is 100. These are the students who did not smoke or drank alcoholic drinks. Then lastly, the students who smoked but did not drink. They smoked but did not drink. So they smoked a C and they did not drink alcohol. So in this case, we'll picture up C, the cigarette smokers. So it will be 80. Thank you, I think you are school.
Okay guys, thank you for watching our video.
Remember to subscribe,
Like, share and comment.